Porous carbon nitride fullerenes PCNF are a novel family of porous Kite molecules. In a new theoretical study, the properties of these compounds were predicted using density functional theory. In contrast to fullerenes, PCNFs contain hexagons only but no pentagons. This is the structure of the molecule C60N60 from two different perspectives. The nitrogen atoms in blue point towards the pores. They are slightly elevated outwards. The diameter of the pores is 4.56 angstrom. In the molecule C120N60, the carbon-carbon bonds within the C4 and 2 hexagons are shorter than the bonds interconnecting the C4 and 2 hexagons. The nitrogen atoms are a bit more elevated outwards than in C60N60. The diameter d of the pores is the same as that of C60N60 pores. This picture shows the corresponding two-dimensional structures to the C60 fullerene and of the carbon nitride fullerenes. Both fullerenes and the two-dimensional compounds contain sp2 hybridized atoms. Graphene is aromatic because the pi bonds are conjugated. Fullerenes are not aromatic because they are not flat. This is the total electron density of the porous carbon nitride fullerenes C60N60 and C120N60. The gap between the highest occupied molecular orbital and the lowest unoccupied molecular orbital is important for the properties of a compound. The smaller C60N60 molecule has a bigger gap than the big molecule C120N60. These diagrams are the predicted values for the thermal stability of the porous carbon nitride fullerenes. C60N60 is stable well above 1000 Kelvin and C120N60 well above 2000 Kelvin. The calculated transition temperature for the fullerene molecule C60 is 3800 Kelvin. 1,3,5-triazine, 1,3,5-triazine, and melamine are potential precursors for a bottom-up synthesis of C60N60. Pyrazine, 1,2-dihydropyrazine, and 1,3,5-benzene triamine are potential precursors for the synthesis of C120N60. Porous carbon nitride fullerenes could be used as catalysts and for trapping small molecules. The Buckminster fullerene C60 is the most known fullerene and an allotrope of carbon. It has the same structure as a soccer football. The pentagons with their bigger ring strain are isolated from each other by the hexagons. Fullerenes exist in nature and they were detected in space. Other known fullerenes are, for example, C70, C74, C80, and C90. Richard Buckminster Fuller was an American architect, inventor, and futurist who liked dome structures. This is a picture of his home. You can check out the links to the scientific articles in the description field, and you can check out my other videos from the chemistry series. Thank you for watching.